Hello, welcome everyone. Good morning, good evening, good afternoon. Welcome to our second edition of IBM Developer Tech Talk series with ConSol, a cloud native story. Today we are going to talk about application security with Keycloak and Quarkus. And my name is Marian and I'm going to be your host today. I'm from the developer advocacy team here in Germany, and I am from Berlin. Usually we start our session by asking you where you are from. So please feel free to tell us in the chat where you're from, and I'm really eager to read. I say hi from Berlin. Oh, hi Alex from Cologne. Oh, Nathan from Heidelberg. Oh, Bilal from France. Cool. Berlin too, Miriam. Great. Düsseldorf, Kassel. Wow. Really diverse today. Really cool. Munich. Awesome. Magdeburg. Irving from Mexico. Wow. Awesome. All right. So, for all of you who have not been able to, as this is the second edition, for all of you who have not been able to attend the first edition of this Tech Talk series, which took place on November 18th, I posted the link to the replay at the beginning of this chat, so you might have to scroll, or I might paste it again. And on that session, Marco talked about how you are going fast with Quarkus, and Marco is back with us again. I'm really happy that you are back again. I'm going to introduce you in a minute, but beforehand, for all of you who are new to the series and may not know what IBM Developer is all about, I would like to say a couple of words about who we are, what we are doing, and yeah, what it is actually all about. So IBM Developer is IBM's initiative to reach out to developers in the ecosystem. And we are a whole organization of developer advocates all around the world, in the UK, in San Francisco, in Tel Aviv. And our mission is actually to inspire, to enable, and share our knowledge with developers like you, and talk about brand new technologies, about topics like hybrid cloud and AI, and of course, open source. And we usually build up on three very important pillars that are the base of our work. The first pillar is code. So you can find thousands of code examples on our website, developer.ibm.com, and I'm going to post the link in the chat right away. The second pillar is content. All of our developer advocates are frequently writing blogs and creating videos and are very active in social media. So the best example is hot off the press, Niklas Heidloff just brought out a very brand new video on the IBM Developer channel on what rabbits have to do with application modernization. So I'm going to paste that link in the chat too. And this brings us to our third really important pillar, which is community, and that's you. We actually are accompanying our digital content with face-to-face developer activities like workshops, free conferences, and all of those are actually held by our developer advocates and experts of the topic like Marco. And before we actually come to the session, let me scroll down a bit. I would like, so I don't forget anything. Before we get to the session, I want to talk a little bit about Crowdcast, so you all know how to handle it. If you have questions, please put them in the Ask a Question section so we can make sure all of your questions are actually being answered. And please feel free to be active in the chat and communicate with us. I'm going to monitor the chat, and last but not least, I will paste a couple of important links right below the session. So you're just one click away from the most important websites that are discussed in the talk. And with that said, I'm going to jump right into our session today. Welcome, Marco Bungert from ConSol. As said, today we are going to talk about application security with Keycloak and Quarkus. So Marco, please tell us a little bit about us, and the stage is yours.
Thank you, Marianne. And I'm going to share my screen and my slides. So today's topic is Keycloak and Quarkus. How can we make our applications secure? And the subtitle is Please Do Not State Your Business. For those of you who want to follow along, I'm going to paste a link in the chat to where you can find the slides. This is a bit.ly link to show you that this link actually doesn't reference any harmful site. I'm going to open it right now so you can see, okay, those are the slides I'm going to present today. Just if you want to follow along, or if something isn't showing up right, you can follow the links and the slides on the links. So, and before we start, I would like to introduce myself. I'm your speaker today. My name is Marco Bungert. I studied bioinformatics and computer science from 2008 to 2013 in Jena, Germany. From 2013 to 18, I was a PhD student in Kassel. And since 2018, I am a software engineer at ConSol. If you want to contact me on our social media, Twitter, GitHub, Bitbucket, Stack Overflow, whatnot, just look for Turing85, normally coupled with this little image of the penguin. The chances are pretty high that's me. What do I do besides Quarkus and Quarkus? The main interest is also Goal VM, so compiling your application natively, but this won't be the topic of today. So before we get started, who of you has experience with Auth2 or IDC? Please write Auth2 or IDC in the chat, so I get a feeling of the crowd we are having today. No replies yet. I see one has OIDC, nothing else. Okay. Next question. Who of you is familiar with, I had a little bit of OIDC and OAuth, admin, OIDC, both. Okay. Who of you has experience with Spring Boot? Just write Spring Boot in the chat. Nothing yet. Nothing yet. SB, Spring Boot, a little bit more Spring Boot. Okay. And who of you has experience with Java EE, Jakarta EE? Just try writing JEE in the chat. Spring Boot. Still Spring Boot coming in. First with JEE, some with JEE. Okay, awesome. So let us get started. What does it mean to be stateless, and why do we want to be stateless? In the good old days, we had monolithic applications. So we were able to keep the authentication and authorization on the server side. And we had a session state that was normally persisted in the server database with some kind of server-side token, which we passed along to the client. And every time the client wanted to make a request, it passed along the token, the server loaded the session, and everything was good. When we wanted to scale our application, we scaled vertically, not horizontally, meaning we updated our RAM, our CPU. We, in essence, deployed a bigger machine. If we are now moving to the cloud, we normally don't scale vertically, but horizontally. And with multiple instances of our application deployed, we have the problem of syncing the session state across multiple instances. We can do this with the traditional quote-unquote approach, but they are complex. For example, we could not store the session in a Redis cluster instead in a database, but this will increase the complexity of our application. And furthermore, we have the problem of social logins. What if you want to allow your customers to log in with Google, Facebook, GitHub, whatever you IDC provider you want to provide or admit? And the solution is quite simple. We won't store the session state in the server side, but we will pass it along to the client in some kind of token. And every time the client wants to make a request, we are going to evaluate this token instead of loading the session from the server. This is where OAuth 2 comes in. It's a protocol for authentication and authorization. It's standardized in RFC 6794. So we don't have a specific login. There are a lot of providers for OAuth 2. We are not bound to a specific implementation. And it also builds the base for OpenID Connect, or short OIDC, better known as social login, so social login with Google, Facebook, and so on. OIDC is also standardized in RFC 8414. And furthermore, we can achieve a single sign-on ecosystem. So your clients only sign on once and can use all the systems in your microservice architecture, for example. Through this, we can achieve a great user experience. So why should we use OAuth 2 as protocol? OAuth 2 is a battle-hardened protocol. It's around for, I think, at least 10 years. We have different flows for different needs. For example, the user can grant specific accesses to specific clients. We will see that in a minute. We have the authentication and authorization without the server state, which is our end goal for using OAuth 2 and OIDC, at least for the talk today. Plus, we have a separation of concern. The authorization server is going to grant the token, so the authorization server only does authentication, really. So it's a little bit of a misnomer to call this server authorization server. It's actually authentication server. And the authorization, who is allowed to access, is done by the resource server. We will see a scheme in a second where we can see this process in the flow. And the authentication state is stored in the front end. With OAuth 2, normally we use JWT tokens, so JSON Web Tokens, which are clear text readable and signed, so they cannot be changed without noticing the change. Exactly. So let us look how the flow normally works. On the left side here, imagine further left here is our end user using a business client, for example, web front end, mobile app, whatsoever. And when the user wants to log in, the business client is going to perform the login through the authorization server. So the business client says, hey, the user wants to log in. Please give me a token. The auth server then verifies the client, gets the user consent. For example, if you allow some apps to access your Google account, you get this little pop-up by Google where you can say, okay, this app is allowed to read my email address and is allowed to make changes in my Google Drive, for example. That is the user consent right here. When the user has granted consent, and keep in mind, part of the granting the consent is verifying the user, so asking for the password. So the business client never sees the user password. A token is returned to the business client. And the business client can then use this token to send it along to the resource server. The resource server will contact again the auth server, presenting the token, saying, hey, can you give me some information about this user? What is his name? What is his or her roles? And is the token still valid? Has it been modified or is it out of time? if the validation is successful, the resource, the auth server will confirm this to the resource server, and the resource server will grant the access to the resource. That's the grand scheme of things how OAuth 2 is working, and by extent OIDC. Furthermore, if we want to use OAuth 2, we have a good support for client libraries, be it in the front end in your JavaScript application or JavaScript front end, or be it on the mobile side of the things. We have a multitude of tools we can use, and are also able to choose here which provider we want to use without logging into one specific provider. So there are quite a lot of OIDC providers out there. For example, there are Auth0, Okta, Keycloak. Why should you use Keycloak specifically? Keycloak is one of the few verified open source and free-to-use OAuth and OIDC providers, so there's no charges for using Keycloak. If you want an exhaustive list, I have linked the website right here, where a list of all known and verified providers are listed. Keycloak is battle-hardened as well. It's around since 2014. It can be hosted on-premise hardware. For example, other providers like Okta and Auth0 are software as a service, so you cannot host them on your own hardware. With Keycloak you can, and Keycloak is quite extensible. So if there's something missing in the Keycloak ecosystem, you are able to write this extension for yourself. We also have user federation in Keycloak. For example, we can integrate LDAP, we can integrate Kerberos, and again, since Keycloak is extensible, you can write your own plugin. Keycloak is also in active development, so it's not a dead project. It's developed by Red Hat, so we have good experience with respect to support and closing security gaps. And if you need, there's also enterprise support available through Red Hat SSO. So that's a paid product by Red Hat. If you need the support, for example, 24/7 support and critical bug fix tickets, you can get an enterprise solution for this as well. Some word of advice. If you use OAuth to manage the access to your cluster, and specifically to your OpenShift cluster or to your Kubernetes cluster, do not deploy the OAuth server within the cluster, or at least deploy it on specific hardware nodes, specific infrastructure nodes, because if the OIDC provider goes down within your cluster and you try to debug it or try to fix it, you have locked yourself out of the system. So best solution would be to deploy the solution outside of the cluster, or to deploy it to specific infrastructure nodes. So I think I skipped something. Exactly. Before we start with the live demo, we need a little bit of nomenclature. The first thing we need to know is, what is a resource owner? The resource owner is the one who owns a resource, typically a user, a natural person. Then we have the authorization server, in our example Keycloak. And again, this is a little bit of a misnomer. The authorization server provides authentication, so it provides the guarantee that the user who claims who he is actually is who he is through, for example, password validation. Then we have the tokens. Tokens are signed and stored in, for example, the front end, so not in the back end, but the front end of things. Signing the tokens prevents modification of the tokens without us noticing it. Then we have the nomenclature of the resource server. That's a backend system providing some resources, for example, details about the user, images, uploads, whatnot. The access to the resource server normally needs a token to access it, and the token is validated, and then the resource server makes the decision of whether or not the user is allowed to access the resource. So the resource server takes over the authorization part of of our application. And finally, we have a client. The client is someone who's making requests on behalf of somebody else. In our case, the client is going to make requests on behalf of the user. Client is the part of the system running in your front end, in your mobile app, making the request, communicating with the server. So let us jump right into the demo. The demo will be split into two parts. In the first part, we are going to look at Keycloak and how to configure it. And in the second part, we are going to look at the program code and how to use Keycloak within your Quarkus application. A little bit of recap of the last talk. We, among other things, provided or implemented a little service. In this case, we have a simple user service with two endpoints, one endpoint right here to post users, and one endpoint right here to create new users. So we have not much business logic on the side, so we can focus solely about OIDC and Keycloak. Are there any questions so far, or is everything clear so far?
There are no questions in the Ask a Question. There's one comment: authentication server is mentioned but not explained from Petro.
Okay. As I said, the term authorization server is a little bit of a misnomer. The difference between authorization and authentication is, let me go back to this slide here. Authentication is a process of validating that you are who you claim to be. So, for example, by providing a password or some token, for example, a timed token. The authorization side of things is deciding whether or not you are allowed to access a resource. And in a typical scenario, the OIDC or OAuth server, in our case Keycloak, just provides the information: is the user the one who he claims he is? So am I really Marco Bungard if I say I'm Marco Bungard? The authorization server or the resource server then decides, is this person allowed to access the resource? So that's the differentiation between these two things. I think it will get a little bit clearer when we look at the code. Are there any other questions so far?
No, you can go on.
Great. So first things first, to use Keycloak, we need to deploy a Keycloak. And I've provided a little Docker Compose file right here. We deploy a database already, and what's new for the ones who were present at the last talk is the OIDC server. Right here, I decided to use the most current version of Keycloak, that is 11.03. And a little bit of configuration, for example, which database vendor I'm going to use. This will reference the DBMS service right here. Login credentials for the database, how the name of the database I'm going to use, in this example Keycloak, and the access information to access the database. To show you how the database is initialized, this little script right here, we create a user called Keycloak_user with a password Keycloak_user, a database Keycloak, and give the Keycloak user access to this resource. So I'm going to fire up this Docker Compose deployment, and then we are going to wait a little bit for the deployment to come up. So exactly. Normally deploying a Keycloak without further configuration takes about 1 to 1.5 minutes. We will just wait until the server is up and running. And then we are going to access Keycloak server and make the necessary configurations we are going to use for this talk. What we are going to provide are a client, so our backend system is able to communicate with our Keycloak server. We are going to provide some users and a little bit of role configuration. I will try to make it interactive, so I will show you all steps along the way. Truth to be told, I'm notorious for misconfiguration by Keycloak, so I have a Keycloak configuration at hand in case I'm going to misconfigure the Keycloak and logged out. So let's get started. You see right here, Keycloak Wildfly. If I can scroll to the right, here should be a message that it's up and running. So we are going to access local host 8090. That's where my Keycloak instance is running right now. Username and password are Keycloak and Keycloak. And we are going to log in. And first thing we are going to see is right here, we have something called a realm. A realm in Keycloak terms is a coarse granular grouping of your users. For example, if you have different applications running on against one Keycloak, you can group them by realms. Realms are not shared, information of realms are not shared between the realms, so we can separate them here. First thing is we are going to create a new realm for our app. We'll call it app. So the realm is created. Next, we are going to do is to create a client for our backend system. For this, we are going to click on client and create. We are going to name it backend - client. It's going to be an OpenID Connect client. The other option would be SAML, which we are not going to use today. We create the client. And now this is important. We will not use a public client. A public client is a client that doesn't need any credentials. We are going to use a client with credentials. So we are going to say this client is confidential. Also, we do not need the standard flow. We are going to use the direct access grant flow. Direct access grant is a specific OAuth2 grant flow to get a user token where the client pass along the password. This should never be used in production. But for the sake of demonstration, it's easiest to use the direct access grant flow so we can issue two tokens quickly and see how the system responds. So that's configured. We are going to save the client. And now we have here a credential tab. We are going to copy this credential right here. We are going to need it later on. I'm going to store it right here, credentials. And what we need to do as well is to go to client scopes. We do not want the role scope. And we are going to define a new mapper, user realm role. I will explain this in a minute. Roles. It's going to be a list of strings, and we are going to save it. Next, we are going to create two groups, a user group and an admin group.
Marco, before you go to the next part, there actually has been a question.
Okay.
Are realms hierarchical?
Could you explain? Could you repeat this?
The question has been, are realms hierarchical?
Hierarchical. No, realms are not hierarchical. So they are flat. They are on the quote-unquote same level. And they are meant for cross grouping your users. As I said before, if you have two different applications running against the same Keycloak and you have different user groups or different user worlds, you can create two realms to run against the same Keycloak. So you have only to deploy one Keycloak instead of two or three. But you could also go along and deploy two Keycloaks separately if that is what the business logic or the application architecture prefers. I hope this answers the question.
Thank you.
So we have two groups right now, users and admins. We are going to make the user group the default group. Oh, that's the wrong tab. Default group as users. Now next, what we are normally going to do is we are adding claims to tokens. In particular, we are going to add roles to our tokens. Roles are the permissions a user has. For this, we have to create the roles. We are going to have 2 roles, one named admin and one named user. And we are going to bind these roles against the corresponding group. We are going now to edit the admin group and say every admin has the role of admin and user. And we are going to assign every user the role of user. The roles are what is going to be put into the token. The groups on the Keycloak level is just to group your users together. Instead of assigning every user a role, we are going to assign users to groups, and the groups will be bound to roles. This makes it easier to add claims and add roles to your user. Instead of managing them separately, you're going to add them to the group to the user. That's is easier for management. Finally, we are going to give our client, this backend client right here, access to the client, not the client scopes, but the scope, admin, and user. This will then, this allows the backend client, which we have provided just a minute ago, to access these 2 rules and to provide them in the token. That's that for our basic Keycloak configuration. And we are going to add 2 users finally. We will add Alice at wander.land. When we add the user in Keycloak, there are no credentials set, so we are going to provide credentials for Alice. In this case, the password is just Alice. Set the password. The password is not allowed to be temporary, and otherwise we cannot log in with Alice. Through the default group, we can see already that Alice is a user, and when we look into the role mappings, Alice has also the role of user through the default group. And finally, we are going to create an admin user, admin at admin.admin. We are going to give the user a password of admin. It's not temporary, and we are going to save the password. So this is a moment where we can check whether or not I have made a mistake in my configuration. I'm going to use Postman now to issue a token for Alice. For this, I need this credential right here. And we are going to post on this resource. As you can see, this here is the location, localhost 8090 of my Keycloak server. We are going to access an app we just provided. We are going to access the OpenID endpoint, and we will issue a token. Now for the body, we have to modify the secret right here. We are going to use the password grant. That's the grant I said you should never use in production, but is used for demonstration. We are going to make the claim, the request as backend client, the client we just provided. We are going to use the client secret. And right here, we have our user credentials. Username is Alice and password is Alice as well. So let us make the request, and hooray, it worked. So now we have actually 2 tokens. The one is an access token. This is the token we are going to use to make our request. The other token, the refresh token, is not used to access the resources, but is used to issue new access tokens. As you can see, the access token right here is valid for 300 seconds, so 5 minutes. The refresh token is longer lived and can be even configured to live indefinitely. With this token, we could issue new access token if this current access token runs out. But we are interested in this token right here. Actually, the token right here is just a base 64 encoding for a JSON. JSON Web Token. There's an awesome site called jwt.io, which is able to decrypt, quote unquote, our token for us. It's not really decryption, but only an obfuscation. We paste the token right here. And now we can see some details about the token we have provided. For example, we have a time when it was issued, expired, and what we can see here as well is we have a preferred username of Alice, email address of alice@wonder.land, and most importantly, we see our roles for Alice. So Alice has the roles user. We can now go along and issue a second token, this time not for Alice, but for our admin client, for our admin user, excuse me. This should work as well, exactly. This token is structured the same, but when we look at this token, we see that admin doesn't have the admin role right here. And when we go back to Keycloak, take a peek at our users, we see, okay, the admin user is not assigned to the admin group. We will change this right here. We will issue a new token, and we will take this token and read it in jwt.io. All right, we have an admin role for our admin user. So that's clear so far? Or are there any questions?
No, it's clear.
Great. So that's the majority out of the way. We are now going to take a look at how to implement some things with Keycloak on our backend. For reference, in the slides, you will find the link to a GitHub repository where you can find all the commits and the code I made. And you don't have to configure Keycloak yourself. I have provided in the Docker container a default configuration that's identical to the configuration I'm using right now. So let's start looking at our resource endpoints. Source main Java. First thing we need to add is a dependency. It's the dependency right here. We tell Quarkus that we want to use the OIDC dependency. So this is the part we add, so Quarkus knows how to communicate with the OIDC service and that we want to make authorization requests with Keycloak. Second, when you look at your application configuration, right here you have a block of OIDC credentials or OIDC settings. First, we need to enable it. Then we are going to make request as a service. This means we don't want to be redirected, for example, on a login or on a missing token. We are a backend service and we expect that the token is present. Otherwise, we just want to have an 403 or 401 error stating that we are not authenticated. Then we have to provide an URL to the actual Keycloak instance. I split it up in multiple variables right here. For one, the server URL as is, and then the realm name. And finally, we have to provide a client with its secret to connect to the client. And as you can see here, backend-client is a client we just created. And this secret is a secret you would get if you deploy the template or the pre-configured realm I just mentioned. For now, I have to replace it with the token I just created a minute ago. That's this one right here. Finally, we have to tell Keycloak where can you find the roles within the token. Here we say it's the roles claim. Yeah. If we take a look at the token right here, this is this part here. And we have to tell Quarkus, where can you find the actual username? That's a principal claim, and this is the preferred _ username. And looking back at our token right here, this is this entry right here. So those are our roles we are going to validate on our backend, and this is the username we are going to use on the backend. You are, of course, free to modify this claim right here if your Keycloak server provides it in another claim or in another structure in the JSON, or if you don't want, for example, to use the username but the email. This is something you can configure right here in this part. Now, how can we use this implementation to now secure our resources? I'm going to open the user resource. And as you can see right here, we have nothing changed here. That means I'm still able to post and get on these two endpoints without authentication. To give you an example, I'm going to get the user Alice. Oh, give me a second. I have to migrate the database first.
While you are migrating,
yes.
there came up another question, Marco.
Yes.
Is a configured client in Keycloak for bearer-only clients necessary?
For bearer-only clients. As far as I know, yes, that would be. Do you mean with bearer-only clients a client that only issues bearer tokens, or should the client only authenticated through the bearer token? But for the first part, we are going to just issue bearer tokens. For this, you need a client, yes. For the second part, I think you have to also provide a client on the Keycloak system, since not every client is allowed to issue tokens. The client must be validated through Keycloak, and thus through the client you need some through the Keycloak you need some configuration on the Keycloak side to validate that yes, this client is allowed to access. I hope this answers the question. If not, please let me know.
Alex commented a client that do create tokens.
Yes, a client that does create tokens must be present on the Keycloak server. That's just what we configured through the process I guided you through. So creating this one client was just done so we can create the bearer tokens I have shown you right here. Those are actually bearer tokens, and we used this client right here, the backend client, with a client secret. Not every client, though, although has to have a password. If you remember, I toggled the client to be confidential. There is the possibility to have a public client, so you don't need a password or a client secret, but this is highly discouraged. You should always have a client secret on your client or some other means of authentication through, for example, MTLS or PKC. Okay. So my database is migrated, my Keycloak and server is started, and now without having a token, I can issue requests. This should, I cannot. Why can I not make this request? Do I already have the annotation? Let me take a look right now why the request isn't going through. Huh. That's funny. Exactly. I have to switch to no authentication right here. And exactly, I'm going to get a not found exception because the user doesn't exist. But in general, you see the request is getting through. So I'm able to query this resource. Now we are going to slightly modify this resource. Let me go to the next commit right here. And the only thing we have changed is for the post endpoint, we only allow admin roles. And for the get endpoint, we are only allow users that had the user rule. keep in mind, we bound the admin group in the Keycloak to both roles, admin and user. So now if I'm going to make the request again, I have no authentication set. I'm going to fetch a user. I'm going to get hopefully a 401, in this case an internal server error. Let me take a quick look. Maybe we have to restart. Yes, we have to restart the Quarkus server. We should see in a second that changing this will result in a 401, I think, that we are unauthorized. Unauthorized meaning we didn't provide any authentication. So here's, cannot find identity. Let me take a quick look. There seems to be something wrong right here. Exactly. I forgot to inject the entity. Let me fix this. Private final identity. Okay, I'm going to take it out for now. I'm going to look it up in a second. We do not need this endpoint for now. And we are going to make the request again. Sorry for that. One more time. Looks like the Democrats are not on our side today. I'm going to restart Quarkus once more. In the meantime, I'm going to look up the configuration I need for the other example to work. Quarkus or IDC. Genau, this part is what I'm going to need. So Keycloak has started. We are going to make the request, and voila, we are getting a 401 unauthorized because we did not provide a token. Now we are going to issue a new token for Alice. I'm going to issue a new token since these tokens are only valid for 5 minutes, and I'm quite sure this token was older than 5 minutes. In Postman, I'm going to add this as a bearer token I just fetched, and I'm going to make the request, and I see I'm forbidden. I'm quite sure I know why I'm forbidden. I made a slight misconfiguration in Keycloak itself. Let me see where Keycloak is, right here. Here I called the name uppercase user, but in my backend system, right here, I have a lowercase user. I'm going to switch this out, and I'm going to make the request again. And exactly, we see, okay, status 404 not found. And the request was able to hit the resource. The user wasn't found, but it was able to hit the resource, so we came through. Next, we are going to look at the post endpoint. That is this one right here. Let me make this in uppercase as well. We are only allowed to post new users when we are admin. And if you remember, our Alice user is not an admin. We are going to try and post a new user with authentication. This is the Alice token I provide. I'm going to send the request, and this is a bad request, not as ignorable. So this and this. And we see we get a 403 forbidden. Yeah. The server was able to see, yes, there is a token. Yes, there is a user associated with a token that I can validate, but the user is missing the right permission to do the request. So now we get the right status code of forbidden. Let us get a token for our admin user right here and make the same request, but this time instead with our admin user credentials. And as we can see, we were able to post on this endpoint. In return, if we are now going to not get Alice, but Bob, Here we have still configured our Alice token, and we are going to send the request. We see, okay, we can get the user Bob as Alice, who is a normal user, not an admin user. And we can only post for admin users. Any questions so far?
No, please move on.
Awesome. Now, what we have done right now, that was one part, wrong part to paste. We have configured only role-based access, but sometimes you want to access the claim itself or the identity itself to use in your code. For this, I'm going to change this and add this. For this, I'm going to inject the claim, so the identity within my service. And then I'm going to provide a little me endpoint, and this me endpoint does nothing else than get me the user associated with the identity, get principal, get name. So I'm going to access the identity, which is, why can you still not resolve it? Because I named it identity. I'm going to access the identity, and the identity will be injected by Quarkus for me through the token. What's interesting here is my resource is application scoped, but the identity is inherently request scoped. So with every request, the identity will change. And Quarkus will take care of that for us, so we don't have to inject it in a method or make this class request scope. We can leave this class application scope, and Quarkus will handling injecting the right identity for each request for us. With this said, we also say only authenticated users can access this me endpoint. And we are going to fetch the user that is given in the token. Let's test this out. I am going to get me right here. Let's do this as Alice. We are going to issue a new token for Alice. We are going to call the me endpoint, and as token, we are going to provide the Alice token. And if everything works out, we don't find Alice because we have never posted her. Let me post her real quickly. Post user body Alice at wonder.land. Let me post it. Forbidden because I have the wrong token again. Give me the admin token. You see, this is the reason why I opted to use the password grant, since it's possible to issue new tokens quickly and to make these changes quickly. Again, I forgot to rename the claims. This is uppercase user. This is uppercase admin. Reissue the token. Thank you. Let me get to the me endpoint. Now we have Alice created, and when we access this endpoint, hooray, we are able to get Alice from the token. Yeah. So, are there any questions so far?
No, there are no questions in the chat yet.
Awesome. So now we are going to add it a little bit more. What we now want to do is we want to remote control our Keycloak. For this, I'm going to shut down my little deployment right here. And we are going to take a look what my approach is going to be. Let me add inject private I already forgot the structure again. That is security identity. security, identity. This should fix this. This should fix that. Awesome. We are going to remote control Keycloak. So that means our backend system, our end goal is if we create a user through the post user endpoint, we also want to create the user in the Keycloak. For this, we have to modify the create request here to also require a password. But our end goal is that we are able to somehow communicate with Keycloak, create this new user in accordance with posting on this endpoint. For this, we have to reconfigure a little bit within Keycloak itself. In essence, we have to, let me take a quick look. Docker Compose. We have to enable an admin client that comes with Keycloak. And we have to give this admin client access to manage all users within the realm. We will see it in a second, but we can already take a look at the implementation. Let me just go one commit forward. For using this remote controlling, we are going to add exactly one dependency, and this is this Quarkus admin Keycloak admin client dependency. There is also a quote-unquote normal Maven dependency that is not Quarkus specific to do this. But if you want to compile natively, you have to use this dependency that comes with the Quarkus. That's a bundle of one of the Quarkus extensions. Otherwise, the program will not compile natively or behave funny at runtime. So let me take a look at the deployment. It should be up and running, exactly. We are going to refresh this page right here. Keycloak. And I'm going to show you the changes that we made right here. We have the admin CLI client. That is the client internally used by Keycloak to administrate a realm. We switched this from public to confidential, and we activated the service account. Furthermore, for the service account, we granted it the client role of realm management, managed users. This is a permission you need on the backend system, this client needs in order to create new users, update passwords, delete users, and whatnot. And now we are going to implement a Keycloak bean to talk to our Keycloak. For this, we have one global structure, one class we have to provide. That's this Keycloak class right here. And we are going to feed into it the server URL, realm name. We need the admin CLI ID. So this is this right here. And we also need to add the admin CLI secret, which is the one right here. On the configuration side of things, I added them to the application.yaml. I think showing you the configuration is not the interesting part. This here is just a simple producer method to create this Keycloak bean, because a bean in and of itself is not a bean. And lastly, we are going to implement our Keycloak service that is going to use the Keycloak. Let me clean this up a little bit. The Keycloak bean we just created, and is going to have a method create account. We are going to pass in a request. And with this request, you can see here we construct the user representation from the request. We contact the Keycloak on the specified realms, get the users, and then we are going to post a new user right here, create. We are going to validate the response to check that, yeah, indeed, the creation was successful. And if not, we are going to throw an exception that tells us what exactly went wrong. Good. So since we have restarted the system, I have to migrate my database. Are there any questions so far?
Yes, in the chat, actually, the users like Katul or Aeropagan have wondered why you are using capital letters, and can you now uncapitalize the role names in Keycloak again, like from a capital user
Yes.
to
yes. As I said before, I'm notoriously bad in configuring the Keycloak on the fly. Capitalizing the roles was a mistake on my side. We can see right here the configuration I provided has not capitalized roles, and yes, you can change the role names. Sorry, no, you can't. I'm a little bit confused. You cannot change the role names when they are created. You can see right here, the field is not modifiable. I cannot change the role name. That means if you misconfigure the role, you have to delete it, you have to create a new role, and you have also to reconfigure the mappings between roles and groups and roles and users. Okay, so far? Are there more questions? There are.
No.
Awesome. So with this configuration done, so we now have a Keycloak service that should be able to create new users. The last step we need is to actually incorporate this part, smart checkout, thank you, within our user service. And when we now create a user, we first check the username already taken, is the email already taken, and then we are going to call our Keycloak service to create our account. Only if this here is going to succeed, we are going to create the user locally. So just a quick look, which users do we have in our Keycloak? We have admin and Alice. Awesome. I'm going to need the backend client secret. This here. I am going to issue one token for our admin client, for our admin user, this one right here. And now I'm going to use this token to post a new user. This is my authentication. In the body, I have to provide, since Alice already exists, we are going to add a new user named Bob, and his password should be Bob. Let me check that the database is migrated before I make this request. Come on, come on, come on. Thank you. Now I'm going to issue this command, and if everything goes well, come on, we get, this can happen when you first start up the Keycloak and make, first configure the application and make the first request, that you get a 500. I found that repeating the request normally solves the issue, which doesn't seem to be the case right now. Variable, I see that I have a misconfiguration in my service. Let me handle this quickly. It's in the user response. Exactly, let me take out this part right here. Now it should be working, and do the request again. Unrecognized. Seems I misconfigured something. Apologies for this. Let me take a quick look. Password not null. This seems to be working. Let me restart the system quickly. This is correct. This is correct. Come on, come on, come on. Apologies for the downtime, but it should be starting right now. Exactly. And now we are going to post, and with a little bit of luck, exactly user Bob was created. And when we now go back to our Keycloak and look at all users, we see actually, yes, user Bob has been created in Keycloak as well. We can now go and log in with user Bob. For example, if I take this request here and I say, no, don't log in as admin, but as Bob, right here. This is a request against Keycloak. I can take this token. I can analyze it through jwt.io. And indeed, we have Bob with an email bob@builder, and he also has the roles user, since this was the default role we provided through the default group. So let me wrap up. If I can find my slides are here. Exactly. So some resources. If you want to now know more about Auth2 and OpenID Connect, here are the two web pages with the documentation. It's worth a read. If you are developing with JWT tokens, I highly recommend using jwt.io. It's a quick tool to analyze your token and to see which claims are present, how are they named. Then there's an awesome Keycloak Getting Started guide, which is also worth to read if you want to use Keycloak. If you want to use Keycloak, for example, within your Kubernetes or locally in your Docker deployment or in OpenShift, there's a Keycloak Docker image. It's really well documented, so you can find all the variables I have set in my Docker compose right here. All those variables are documented. You can read up what they do exactly. You should take a look. And last but not least, you can find the code for, I presented today under this GitHub repository. I'm going to fix the code issues we had and repush it so you have a clean base to work on. Also, if you are interested and if you say, okay, Quarkus plus Keycloak is awesome and I want to know more, we as ConSol provide workshop with Quarkus, and one part of this workshop is also Keycloak configuration and a little bit more about how to use Quarkus and Keycloak, for example, when you make REST calls from one service to another, how to pass along the tokens, and so on. So let us recap. We have discussed what OAuth is, what authentication authorization is without server state. We have taken a look at Keycloak as open source, free to use and verified provider. We have configured a complete Keycloak. We have talked a little bit about user federation, so using LDAP and domains. And we have configured the Keycloak with client users roles. We have defined a little mapper, and on the implementation side of things, we have used the tokens within our Quarkus backend to validate the tokens, and furthermore, we remote controlled Keycloak, so our backend service was able to create new users on the fly in Keycloak. That's it. Thank you for your attention. And if you have any questions, please feel free to ask.
Thank you, Marco. I don't see any questions in the chat, so I'm gonna wrap up. Thank you for being with us today, Marco. And thank you everybody for joining this, again, really interesting session today. At this point, I'd like to mention that our open source project Cloud Native Starter also is using Keycloak for security. So I posted the link in the chat. So if you're interested, take a look. It's open source and it's all on GitHub. And for your attendees, please take some time, if you can, to fill out our survey. I posted the link in the chat because we really are eager to hear your feedback in order to make the next session even more interesting and better, not more interesting, better, sorry, better for you, like the next experience. Also, don't miss out on the next part of the series. It's going to be in the new year on January 13th, at the same time, actually, 4 to 5. And Sebastian Tickelkamp is actually going to tell us more about continuous integration and continuous development and GitOps. So I posted the link in the chat, maybe not, and I'm going to post it now so it can directly save your spot. Here we go. And with that said, it's time for me to say goodbye. Thank you again for being here with us today, and I wish you all a nice evening, a nice morning, a nice rest of the day, and take care. And bye-bye. I'm going to close the broadcast now.
Thank you for having me. Bye.
Goodbye.